Hey everybody, welcome to Geometry, Section 8.5, Law of Sines. By the end of this lesson, you should be able to use the law of sines to solve for a missing angle, use the law of sines to solve for a missing side, and use the law of sines to solve the entire triangle. When we say solve the triangle, that means you got to find every angle and every side. So let's talk about what the law of sines is. So let's say we have a triangle ABC. What the law of sines will allow you to do is find missing sides or missing angles. And the nice thing about this is it doesn't have to be a right triangle. When we use sine, cosine, and tangent, it had to be a right triangle. With law of sines, it can be any triangle. So first thing I want to do is I want to identify the sides. So we know angle A, angle B, angle C. But a shorthand for labeling the sides is using lowercase letters. So for instance, side BC, we could also call side A, but we use a lowercase a. Instead of endpoint B and endpoint C and calling it BC, we just call it A because it's the side directly across from angle A. And likewise, side B is directly across from angle B, and side C is directly across from angle C. So here's what the law of sines is. It says the sine of angle A divided by A, that creates a ratio. And that ratio is equal to the sine of B divided by B, the sine of angle C divided by side C. All right, so that's the law of sines. Pretty easy to remember too. So when do you use the law of sines? You use the law of sines on any triangle, not just right triangles. That's the main draw to being able to use the law of sines. But in order to use the law of sines, you have to have an angle and its opposite side. So you either have to have angle A and side A, or angle B and side B, or angle C and side C. Okay, you've got to have a full ratio in there. And you need to have one other piece of information. Okay, it doesn't matter whether it's an angle or a side. It doesn't matter. You just need to have one other piece of information. So here we see the law of sines, and here we have an example. So I've got two angles, and I'm looking for one of the sides. So I have that angle, which is 39.4, and the side opposite of that. Okay, so I've got an angle and its opposite side, and I have one other piece of information, that 46.5 angle. So I'm going to use that to figure out what x is. So when you're using the law of sines, you don't have to use all three ratios at once. You can either use the first two, the last two, or the first last. It doesn't matter. Just you only use two ratios at a time. Okay, so you don't set up a three-part equation. So what I'm going to do is I'm going to go ahead and set it up the sine of 39.4 over 7 as my first ratio. And then that's going to be equal to the sine of 46.5 over x. And that's all I have to do to set up the law of sines. Okay? So now, since I've got one ratio equals another ratio, that's a proportion. And we can solve any proportion by cross multiplying. So I will go ahead and do x times the sine of 39.4, and then equals 7 times the sine of 46.5. Okay, so I no longer have any fractions, but at this point I want to get the variable all by itself. So if I take a look, x is multiplying the sine of 39.4. So to get that by itself, I'm going to have to divide both sides by 39.4. The sine of 39.4. So when I do that, then the sine of 39.4 will cancel out on both sides. And then that's what I'm going to have to do is I'm going to have to plug that into my calculator. So 7 times the sine of 46.5 divided by the sine of 39.4. Now, I'll be real honest with you. If you guys try to do this with your cell phone calculator, it's going to be a pain in the butt. And you say, well, if you turn it this way, you see the sine and cosine and tangent. True. But even some scientific calculators, it doesn't, if you type it in directly, it doesn't follow. So what I have to do on this one is I have to do 46.5 and then hit the sine button. And again, make sure that your calculator is in degrees, not radians. And then I have to do times 7 and then divided by 39.4, and then hit the sign button. And that gives me 7.9996. Okay. So my rule of thumb is to round to two places. So 7.999 would round to 8.00, or just 8. Now, everything I said with how I'm typing this in on my calculator can be avoided if you have the right calculator. If you have the right calculator, you can just literally type in 7 times sine of 46.5 divided by sine of 39.4. Okay? If you have that calculator, great. Hang on to it. Learn how to use it. Because if you have to use your cell phone as a calculator, which you can't on a test or a quiz anyway, it's a real pain in the butt to get that to happen. Okay? So take a look at that answer of 8.0 or 7.999. If you're not getting that answer, then next time we meet in person, we need to talk about how you use your calculator. Okay? So we can also use the law of sines to find a missing angle. And we'll set it up the same way. I've got an angle and the side opposite of that. So I'll set it up as sine of 35 over 14. And then I need to find, I'm going to find angle x, which I just drew the x in there. But that's the only angle I can find if I know that that side is 17. So then it's the sine of x over 17. Okay? So let's let that setup sink in for a second. So now that I've got it set up, I can go ahead and do cross multiply. So 17 times the sine of 35 equals 14 times the sine of x. So now the fractions are gone. Now I want to start getting that variable by itself. So I see that I can divide by 14 on both sides, so I'll go ahead and do that. The 14s cancel out, and so then I've got 17 times the sine of 35 divided by 14 equals the sine of x. Well, x isn't quite by itself yet. It's still got that sign there. And if you remember from a previous lesson, the way we undo sine is by doing the inverse sine to both sides. So I do that, and of course the only reason that inverse sine exists is to undo sine. So on the right-hand side of the equation, the sine and the inverse sine will cancel each other out, and I get the inverse sine of 17 times the sine of 35 over 14 equals x. Now again, if you're trying to use your cell phone calculator, that's going to be nearly impossible to put in unless you're like really, really good with math. So again, make sure you have the right kind of calculator. But you'll type in inverse sine, parentheses, 17 times sine of 35 divided by 14, end parentheses, and you should get 44 degrees. Okay? With an angle, I always round to the nearest whole degree, so 44 degrees. So let's go ahead and do this. Let's do a few more examples and see how we can use the law of sines on some problems. All right, so here we have another similar example to what we did in the slideshow. So it says find AB. So let's go ahead and mark that up. And so I can set up the ratio sine of 44 over 7 equals sine of 53 over x. Cross multiply, so x times the sine of 44 equals 7 times the sine of 53. Then we can start getting the variable by itself. So let's divide by the sine of 44. And then that's what I'm going to type in my calculator. 7 times the sine of 53 divided by the sine of 44. So I'm coming up with 8.0477. So rounded to two places, that would be 8.05. Now, a good way to double check yourself is that the biggest angle will always be across from the biggest side, and the smallest angle will always be across from the smallest side. So if x is 8.05, does it make sense that the smaller angle, 44, is across from the smaller side, 7, and the bigger angle, 53, is across from the bigger side, 8? That does make sense. So I'm pretty confident in my answer. Again, if you're not getting the same answer, we need to talk about how you're plugging things into your calculator. Let's do another one. So it says find AC. So I've got the 22, which is directly across from the x, so I can set up sine of 22 over x equals, and then for the 24, I don't have the opposite angle. So I've got the 118, but the 118 would go with side A. So what I have to do in this case is I have to figure out what angle C is. And I could do that because all three angles will add up to 180. So if I take 118 plus 22, that's 140. So subtract that from 180, and I know that angle C is 40 degrees. So that's real nice when you already have two of the angles. You can figure out the third, no problem. So now I can set up sine of 40 degrees over 24. Cross multiply. So 24 times the sine of 22 equals x times the sine of 40 degrees. Divide both sides by the sine of 40 so you can get x all by itself. So sine of 40 cancels with sine of 40. And then this is what I'm going to plug into my calculator. 24 times the sine of 22 divided by the sine of 40. So the sine of 22 times 24 divided by 40. And I'm getting 13.986. So rounded to two places would be 13.99. Let me do my little double check. So the 13.99 is across from the 22, and the 40 degrees is across from the 24. So I've got the smaller side, which is 13.99, across from the smaller angle, and the bigger side, 24, across from the bigger angle, which is 40. So that matches with what we know to be true. So I feel pretty confident in knowing that x is 13.99. Next example, let's find BC. So we're in a similar situation to what we were two problems ago, or just the last problem, where like I've got 27 here, but I don't have angle B. So I need to figure out what angle B is. So if I add up the 31 plus the 59, that makes 90. Subtract that from 180, and I get that B is 90 degrees. I'm going to go ahead and stop right there because we're in a unique situation. Because B is exactly 90 degrees, this is suddenly a right triangle, and I no longer need the law of sines. I can now use just regular trigonometry, sine, cosine, and tangent. So here's how we're going to do this. If I use the 39 degree as my angle, x is the opposite, and 27 is the hypo. So opposite and hypotenuse, that's sine. So sine of 39 degrees equals x over 27. Multiply by 27 on both sides. And now I have x all by itself. So 27 times the sine of 39. And I get 16.991. So 16.99. Well, that was a little bit easier than the law of sines. So if you can use trigonometry, do it. But law of sines works for any triangle. All right. Next to last example here says find the measure of angle C. So we've found a lot of missing lengths, but we haven't found a whole lot of missing angles, except for in the slideshow. So let's go ahead and get some extra practice with that. So I've got this angle and the opposite side. So sine of 88 over 26. And then if I want to find angle C, that's going to be opposite of the 21. So sine of C over 21. Let's do some cross multiplying. So 21 times the sine of 88 equals 26 times the sine of C. The fractions are gone, so let's worry about getting that variable by itself. So I'm going to divide both sides by 26. Now I'm close to having the variable by itself, but it's still got that sign there. So if you recall, the way we undo sine is by using the inverse sine. So I will do the inverse sine to both sides. With the idea that the inverse sine and the sine cancel each other out. Now this is a handful to put in your calculator, but I have to do the inverse sine of 21 times the sine of 88 divided by 26. So I'm getting 53.82. If I round that to the nearest whole degree, that would be 54 degrees. Final answer. So hopefully you guys were doing that along with me, so that way you can kind of see if you're using your calculator correctly. It'd be a shame if you understood all the material up to that, but you got the problem wrong just because you couldn't put it in your calculator right. All right, last example. It says solve the triangle. That means you've got to find every single angle, every single side. So I just took a look at this, and this triangle cannot be solved by using the law of sines. So because I kind of copied the problem from someone else, I'm just going to go ahead and rearrange this. And I'm going to make this 18 centimeters and pretend that we don't know this side. Okay? I'm the teacher. I can do that. So the reason I did that is because now I have an angle and its opposite side, and then one other piece of information. So what I'm going to do is I'm going to start off with the law, or the sine of 99 over 18. And then I'm going to use that 11 centimeters to help me find angle F. So that will be the sine of F over 11. So now I can go ahead and cross multiply. So 11 times the sine of 99 equals 18 times the sine of F. And let's divide by that 18 so we can start getting f by itself. So those 18s cancel out. And I know this takes a while to write all this, but I'm making sure that I take my time so that way I'm not confused in all of my steps. I know so many students want to just rush through it and get the answer, and I'm just going to plug it all into my calculator, and then they mess up somehow and they get all confused because they didn't take their time. So now to get angle f by itself, I have to undo the sign. So I'm going to do the inverse sine to both sides. So this sine cancels, the inverse sine cancels out this sine, and I get angle f. And then I'm going to type that whole thing into my calculator. So divided by 18. And I get 37.12 degrees, so 37 degrees. Okay, so when it says solve the triangle, we got to find every single side and every single angle. So I've found two of the angles now. I've got two of the sides. Well, we are in luck because we can figure out that third angle by just taking the 99 and the 37 and subtracting it from 180. So when I add that up, I get 136, and then take 136 and subtract it from 180, and we're looking at 44. So now I can use that 44 degrees to help me find side E. So I can start with the same ratio that I did before. I can still start with the sine of 99 over 18, and then equals sine of 44 over E. Cross multiply, so E times the sine of 99 equals 18 times the sine of 44. And let's start getting that E all by itself by dividing by the sine of 99. So those cancel out, and I get E all by itself. So that's what I type in my calculator. 18 times the sine of 44 divided by the sine of 99. And I'm coming up with 12.659, so 12.66. So now, if I've done this right, the largest angle is across from the largest side, the smallest angle is across from the smallest side. So the smallest angle is 37, and it's across from 11, which is the smallest side. The largest angle is 99, it's across from 18, which is the largest side. So that's a pretty good indicator that we've done some stuff right. Okay, so we have successfully solved the entire triangle. We've got all three sides, all three angles. And it's a little bit of work, but it can be done. So hopefully you guys didn't find this too difficult. It's kind of liberating to use this without having to have a right triangle. So if you guys have any questions, please feel free to ask me either in person or email me. And I hope you guys have a good one, and I'll see you real soon.